Hey, welcome to The Explainer. Today, we're going to dig deep into a really cool geological mystery. How does our planet actually make its hidden treasures? We're talking about the science of ore, which is, the very foundation of our modern world.
So let's kick things off with a bit of a puzzle. We know for a fact that metals, things like iron, copper, gold, they're basic building blocks of our planet's rock. I mean, they're pretty much everywhere you look in the Earth's crust. Okay, so if that's true, why are we all just digging in our backyards and striking it rich? Why can't we just mine anywhere we want? And that's the real question, right? It's the problem geologists have to solve every single day. To get to the bottom of this, we've got to understand a key term. We're not just looking for metal. We're looking for an ore deposit. And what is that? Well, it's a special place where nature has basically done all the heavy lifting for us, concentrating a metal so much that it's actually worth our time to mine it. Without that concentration, it's not ore. Okay, this right here, this is the golden rule you need to remember for this whole explainer. To make treasure, the Earth has to do two things. First, it's got to separate the good stuff from all the worthless rock around it, and second, it has to gather all that good stuff into one specific spot. It's all about separation and concentration.
So how does the Earth actually pull this off? Well, it turns out our planet has a whole bag of tricks to get the job done. So let's jump in and look at 5 of its cleverest methods.
All right, method number 1. This one starts way, way down deep inside the Earth with something we've all heard of, molten rock, or magma. The sorting process can start right there, before the rock is even fully solid, and it's all about raw power. What's so cool is that this whole thing is really just basic physics at work. As this giant chamber of magma starts to cool down, some minerals freeze at hotter temperatures than others. And it just so happens that the heaviest, densest ones, which carry awesome metals like chromium and platinum, crystallize early and then sink to the bottom. They literally form a super rich layer down there.
And if that sounds familiar, it should. It's the exact same idea a gold prospector uses with their pan. You swirl it all around, the heavy gold sinks to the bottom, and all the light sand and gravel gets washed away. The only difference is the magma chamber is doing this on a ridiculously massive scale.
Now, if magma is the brute force method, this next one is all about finesse, and it's probably the most important process for creating many of the metals we use every day, from gold all the way to copper. And here, the hero of our story is super hot water working deep underground.
So here's how it works. You have this incredibly hot water, right? It's like the ultimate solvent. It moves through the Earth's crust, dissolving tiny little bits of metal from huge amounts of rock. Then, this metal-rich hot water flows through cracks. But when it starts to cool down, or the pressure changes, it just can't hold on to all those metals anymore. So what happens? They crystallize out, forming these amazing rich veins.
The real magic trick here is that change in conditions. Think about it. You can dissolve a ton of sugar in a hot cup of tea, no problem. But what happens when that tea gets cold? The sugar starts to crystallize out at the bottom. That is exactly what's happening deep in the Earth's crust. But instead of sugar, we're talking about gold and silver.
Okay, method number 3. For this one, we're coming back up to the surface. We've talked about heat and underground plumbing, but now we're talking about the slow and steady forces that you and I see all the time. This one uses the power of water and gravity, working over millions of years to sort everything out.
And what's interesting is there are actually a couple of different ways this happens. First, there's physical sorting, which creates something called a placer deposit. Just picture a river tumbling rocks downstream. The heavy stuff, like gold nuggets or even diamonds, it just settles out and gets stuck in the riverbed, while the lightweight sand just washes away. Then there's the chemical side, where huge ancient seas full of dissolved iron just evaporated. And what do they leave behind? These absolutely massive layered deposits of iron ore. So we've talked about molten rock, we've talked about water on the surface, but what happens when you take rocks that are already there and put them under some serious stress? Well, that brings us to metamorphism. This is basically where the Earth recycles and upgrades its own work.
So, when tectonic plates crash together, they can bury rocks deep in the crust where the heat and pressure are just immense. The rocks get literally cooked. This process can squeeze metal-rich fluids out of the rock. It's kind of like wringing out a sponge. These fluids then travel and drop their metal somewhere else, often turning a low-grade deposit into a much, much richer one.
All right, our 5th and final method. We're heading right back up to the surface for this one, and you'll never guess what drives it. Just the everyday weather. It's an amazing example of how something as simple as rain can help create treasure. This is such a cool example of nature basically upgrading its own handiwork. See, rainwater is just a little bit acidic, so as it trickles through the ground, it can dissolve metals like copper from the top of an existing ore deposit. Then, that metal-rich water seeps down and redeposits all that copper at a lower level. What you get is a new secondary enrichment zone that can be way richer than the original stuff was.
So look, if you remember one thing from all this, make it this analogy. All 5 of these methods are really just different ways the Earth makes juice concentrate. It starts with rock that has just a tiny bit of metal, that's the raw fruit. Then it uses magma, water, pressure, or weather to squeeze and concentrate those metals into a rich, valuable final product.
And boom, that takes us right back to where we started. Why don't we mine everywhere? The answer is actually pretty simple. The bottom line is the metal itself, it's common, it's everywhere. But the special set of geological circumstances that concentrates it into an ore deposit, that's what's rare. And that's what makes it treasure.
Okay, let's do a quick recap and put all 5 of these methods on one page. You've got magmatic, with its cooling magma, hydrothermal, with hot fluids, sedimentary, using water and gravity, metamorphic, with heat and pressure, and supergene, with weathering. From the insane heat of a magma chamber to the gentle dripping of rainwater, each process is a specialist. They're like nature's master chefs, each with a different recipe for making treasure.
And here you have it. This is the whole thing, boiled down into one single sentence. Treasure isn't just found, it's made. It's the end product of these incredibly powerful forces: magma, water, gravity, chemistry, all working over millions and millions of years to take something that was spread out and concentrate it all in one place.
So you see, the real takeaway here isn't just about gold or copper. It's about this incredible power of concentration. The metals aren't the rare part, the process is. It really makes you wonder, if these same systems can concentrate metals, what other incredible treasures has the Earth hidden away for us, just waiting to be discovered?